right, some of you guys have been requesting some help with some factoring problems, and solving quadratics through factoring. So I came up with a few questions to help you with that. So I'm going to go through one of each of the types of factoring that we've covered in class. So this one, okay, is one where we're going to practice using the greatest common factor. We're just factoring out the greatest common factor. So if you look at this one, you need to first pay attention to all of the terms and try to figure out what factor they all share. So if you look at this one, the greatest factor that those coefficients share would be a 2. Okay, and then if you look at each term, you see they at least all have an x. So we're going to factor out a 2x from everything in this polynomial. So 2 divided by 2 is just 1, and then x cubed, if you factor out an x, you're going to have x squared remaining. Okay, and then if you factor out a 2 from the 8, you're going to have a factor of 4 left. So, because 8 divided by 2 is 4. So that's 4. And then we factor out an x from the x squared, we're going to have an x remaining. And then negative 12, if you factor out that 2, you're going to have a negative 6 here. And we factored out that x. So we have factored out the greatest common factor. So this is one factor of this polynomial. And this is one factor of this polynomial. But you can notice this one, you could possibly break down further. So to see if it would factor any further, we're going to make our x. Okay, and remember you multiply a times c. So 1 times negative 6 is negative 6. And then the 4 goes here. Okay, because the b goes right here. Now you're trying to think, are there 2 factors that multiply to give you negative 6, but add to give you 4? So let's think about all the factors of 6. So 6, we know, has a factor of 6 and 1, so you can try combinations of that. All right, so are there any combination, positive or negative, that are going to go on these sides that would add up to give you 4? There's not, so that doesn't work. What are the other factors of 6 you can try? The other factors would be 3 and 2. All right, you can try those here. So any combinations of those, would they add to give you 4? So what I mean by that, you could have negative 3 and positive 2, which that would add to give you negative 1, not 4. Or 3 and negative 2, which would be 1 here, not 4. So this is as far as you can go on this one. You have factored it. Boom. All right, so that was one where you're just factoring out the greatest common factor. All right, this one is one of the more basic quadratic factoring problems where you're going to factor one that has a, so that leading coefficient on the front, that's 1. All right, so these are the easier of the quadratic problems for you to factor. So what you do is you make your x here, and we're going to multiply a times c, so 1 times 5 is 5. Okay, and then you put your b here. So you're thinking of factors of this 5. You want 2 numbers that multiply to give you 5, but they have to add to give you negative 6. So remember, if they're multiplying to give you a positive, that tells you something about their signs. They're either both going to be positive or they're both going to be negative. But then you look to see what they have to add up to give you. If they're both adding to give you a negative, right, that means both of these factors are going to need to be negative. All right, so now think of some factors of 5 that would work. So 5 and 1 will be your factors. So negative 5 times negative 1 does give us positive 5. Negative 5 plus negative 1 does give you negative 6. So we're going to write this as factors. Whoops, the row squared, definitely not squared. There we go. So these are your 2 factors, right? And this one's not one you're factoring by grouping because your a was not 1. All right, so now I gave you another third and final example I'm going to put on this video is this one. So this is example 3. In example 3, you notice that the a is not 1. So your very first thing you would want to do is try to factor out a greatest common factor if you can. So if you look at those coefficients, I gave you 6, 13, and negative 5. The only factor that they share is a 1. So we don't need to do the factoring out the greatest common factor. That's not going to be helpful for this one. So I'm going to demonstrate first how you would factor this one by grouping, and then I'm going to remind you of that bottoms up trick that I taught you before we got out for our little quarantine. All right, so here we go. We are going to make our x, right? You're going to multiply the 6 times the negative 5, which gives us negative 30. All right, and then you bring your b and put it here. All right, so now you're trying to find out what 2 numbers multiply to give you negative 30 and then add to give you 13. So you could sit there and you could come up with a factor tree for 30 if you struggle with this one. But we know that these are gonna have to be opposite signs. One's positive and one's negative, since this is a negative number that they have to multiply to give you. All right, and then if you think of some factors that would sum to give you 13, it's going to be positive 15 and negative 2. Because 15 times negative 2, it is negative 30. 15 minus 2 is 13. So those are our two numbers. They are not our final factors. Those are the two numbers we're going to replace b with. So we're going to take out this 13x and we're replacing it with these two. So we have 6x squared plus 15x minus 2x minus 5. So what I've done here is I've taken that 13x and I've broken it into these two terms. I haven't changed the value of the expression because 15x minus 2x is still 13x. I just broke it apart so now we could try to factor it. So now that we've done that, we're going to factor by grouping, similar to the other video that I posted on our Canvas page. So I'll demonstrate this one again though. So we're going to factor out the greatest common factor between these two. So the greatest common factor between these two would be 3x. So we're going to factor out a 3 and an x from both of those. So if you factor out a 3 from 6, you're going to be left with 2. And if you factor out an x from x squared, you're going to be left with 2x there. All right, and then if you factor out a 3 from 15, you're going to have 5. So we have plus 5, and that x is gone because we factored it out. So this expression, I factored down to these two. All right, now this grouping, remember, you want the part in the parentheses that remain, if it's factorable, you want those to be the same factors. So we don't want to just leave it as negative 2x minus 5. We want it to be 2x plus 5. So we need to factor out a negative 1. So we're going to factor out a negative 1. So now that what remains in the parentheses is the same factor. So now this is why it's called factoring by grouping. We've grouped it, and now we're going to factor out from the two groups their common factor, which would be 2x plus 5. So I'm going to factor out 2x plus 5 from this group and this group, so it's coming out, and what's left is going to be the other factor. So what would be remaining if you took that 2x plus 5 out would be 3x minus 1. So if you were just simply asked to factor them, this would be what you stopped with. If it asked you to solve it, then you would set these two factors equal to 0. All right, so I told you I would show you that this is factoring by grouping. All right, and I did show you guys another method. I called it the bottoms up trick. I'm just going to remind you of that again. So if this is what you had been factoring and you were using your shortcut instead of factoring by grouping, all right, you still would have made this as normal, but you would have skipped to this part and gone straight to writing it out as a factor. But you see, that's not our answer, right? All right, the factoring by grouping got us this, right? The bottoms up trick, you have to remember you have to divide these factors by a. So what was our a? It was 6, so we're going to go divide these by 6. Okay. All right, and here's the part you got to remember. So if you're using the shortcut, I remember we want our answer to be this because this is the correct answer using the algebraic method, right, of factoring by grouping. What we're going to have to do is simplify these fractions if you can. So what does 6 simplify to? 3 is a factor of both of them, so you would have 5 halves. All right, and then what does 6 simplify to? 2 is a factor of each, right? So it would be x minus 1/3. Okay, and then now here's the shortcut. It's called bottoms up. The bottom of the fraction, well, first of all, if it's a whole number, you're done. It would be like x plus 5 if that had been a whole number, but it wasn't. It was x plus 5 halves, so the bottom comes up. That's why we call it bottoms up trick. All right, so you see how that matches this one? All right, and then the bottom of this one comes up also. So bottoms up. Boom, there's our factors. So those are your factors. This is called the bottoms up trick. Boom, there they are. So I hope this helped you. Use this to help you. Some of you were asking about the question where you had to drag them and match them.